Hi, welcome to Chapter 3. Chapter 3 starts getting into how we can break pieces of our code out into modules. And what that allows us to do is to not have code that's repeated. Okay, that's one thing we never want to do is repeat the same code over and over again. If we do that, then what we want to do is, so basically what I'm saying is no duplication of code. If you're going to have duplication of code, put that code in a module and then call it. So that's what this is basically getting into. So again, it's simpler code, it's code reuse, it's better testing, it's easier maintenance. So this is a great example. So if we just have statement, and let's say this group of statements right here is repeated here and repeated here and repeated here, then it doesn't make sense. So what we then do is we take those statements and put them in a module. In our main, we call that, it executes those lines of code. We come back, we call them again, we call them again, we call them again. And another reason we want to do this is if you have to have a change to that code, what will happen is that code will be changed in one spot and not changed in another. So if we don't have it in modulars, in modular construction, what will happen is that code will go along and okay, we duplicate it here, we duplicate it here. If we need to change that code, we make a change here, we make a change here, but we forgot about it down here. Now the program doesn't work correctly. So again, never ever duplicate code. Another reason we do it is to break out our program. We shouldn't have a program, or our main shouldn't be this long. I mean, just super huge. What we do is maybe our read will be in a separate module. Our write will be in another separate module. Our calculations will be in another module. So we kind of modularize it that way. It's kind of like instead of this one big long string of code, we break it out into separate pieces. Another reason we might do that is in a professional, some companies, a big, huge program, we can have separate groups of people working on those different pieces so that there's no one specific person. We might have our expertise on the calculations, our expertise on reading a DB2 file, our expertise on writing out to some type of screen report or something to that effect. That way there, the folks who know just the calculations can work just on the calculations. Okay, and that's kind of what they talked about here, facilitating teamwork. So what we need to do is we will basically have a module, and let's just get right into it. So right here we're going to have a project main, and we're going to display I have a message for you. We're going to call this module, this procedure called show message, and it's going to say display hello world, and then when it comes back it's going to display that's all folks. So how do we do this in Raptor? So here's how we do this in Raptor. So I come in here and I'm going to display an output message. So I put in an output message. Okay, it wants me to save first. Okay, so I put in there that remember we have to put all of our text in double quotes, and I have a message for you. And now it wants me to call show messages. The first thing I have to do is I just come up here where I have this main tab. I do a right click and I say add procedure. So when I add a procedure, I'm going to call this show message, and that's all I'm going to do because this is where I can pass parameters or receive parameters back. I click OK, and there it is. Okay, so let's go back to show main for a second. So I come over here. Here I've got this block called call. I click on that, and I click just after that, and it says what do you want? I type SHOW. Notice it shows up down below here. When that shows up, I can just hit the enter key, and there it shows up. Now, since I'm not passing anything to it, I don't need to put the parentheses. We'll talk about that a little bit later. So I've got show message, and then I'm going to display another output below that that says that's all, folks. So I put double quote. That's now I can use a single quote inside of the double quote. That's fine. That's all, comma, folks, exclamation point. Okay, so the main is done. So I come over here to show message, and that all I'm going to do is just double click. I'm going to put arm, so I'm going to put this output right there. Double click, double quote, hello world, end the double quote, and it's done. Okay, I save it, come back to my main, I go ahead and I click run, and it comes up and says I have a message for you. It calls that. Okay, so let's just step through it. So here's one thing we can do in Raptor is I can do a right click right here on the show message, and I can say toggle a breakpoint. Okay, puts a little red dot in there. So now when I run this again, I'm going to clear my output. When I run it again, it stops right there. And now I've got this little triangle with a pipe symbol on there. I can step through this box by box. So I click on it, it goes over to start of the show message. It comes in, it says, first of all, notice it says I have a message for you. Boom, now it says hello world. Boom, now it goes back. Now where does it go back to? When it's returning from a called module, it comes back to the very next statement after the call. Okay, which happens to be put, that's all, folks, which is output. Notice it's not here yet because we haven't executed it yet. I click on it, it displays it, it's now at the end. I click on that, boom, the program is now over. Okay, so notice how it went down, it called that module, and when it comes back, it goes back to the very next executable item after the call. Okay. In flow charting, which we're using Raptor, a flow charting symbol for a procedure call or a module call is this box with these two lines on the side. And notice our main, and we have our show message. Okay, so just realize, put that in the back of your mind. So here is what is called a hierarchy chart. If we had a very huge, super complex program that had a bunch of module calls, this is what we would basically have to show the different modules that are within this particular program. So we've got our main. The main calls get input, calculate gross pay, calculate overtime, calculate withholding, calculate net pay. Inside of the get input, it calls get hours worked and get hourly pay rate. Inside of the calculate withholdings, it calls get tax or calculate taxes and calculate benefits. So kind of getting back to that teamwork thing, we might have folks who are just specific in calculating the benefits or the taxing or all that stuff, and in that area they work on just that part of the program. Okay, so so here we have in the spotlight, and here's basically what it wants to do. We're going to have a starting message, explain what the program does. We're going to basically ask the user to press the key to see step 1, display step 1, ask the user to see step 2, do step 2. Okay, so here's what it looks like in pseudocode. So we call the starting message, so we call a module. That starting message basically says this program tells you to disassemble the Acme laundry dryer. There are 4 steps to this process. Okay, it comes back and it displays press a key to see step 1. We get that input. Okay, we call step 1. Step 1 is basically going to say step 1, unplug your dryer, move it away from the wall, and it basically returns. And it goes to step 2, step 3. So let's see what that looks like in Raptor. We're not going to write this because I already have it coded. So this is what it looks like. So here's my start. I call starting message. I say press a key to, now this is an input. This is an input box, okay? I could have used an output box, but since they're asking for an input, I went ahead and did an input box. Where it's, and we'll show what that does in a second. And it calls a step 1 process. And then it says another input box. It says press a key to get step 2. If I open up this input box, it basically says press the key to see step 1, and I have a variable called step 1. Now, I'm not expecting anything. I'm not expecting anybody to input anything, but well, let's take a look at it. So here's my starting message box, and it says this is a program that tells you how to disassemble an Acme laundry dryer. These are all output boxes, and there are 4 steps to this process. Okay. Step 1 says, it's an output box. It says step 1, unplug the dryer and move it away from the wall. Now, why would we have that in 2 separate boxes? Well, it's because we want it displayed on 2 separate lines. Okay, so that's one displays it on one line, the next one displays it on another. If not, it would display it on one big long line. Step 2, it basically is going to say remove the 6 screws from the back of the dryer. Step 3 says remove the dryer's back panel. Step 4, pull the top of the dryer straight up. Okay, so let's do this. Let's put a toggle breakpoint right here for the starting message. So we run it. We're going to call the starting message. We're at start now. It says put this program, boom. This program tells you how to, boom, disassemble an Acme laundry dryer, boom. There are 4 steps to this process. Now we're at the end. We're at the end of this. By the way, I think they're getting their dryer at the same place that Coyote and Roadrunner get their stuff. Anyways, so here's the end. We hit that. Boom, it goes right back. And where does it go? Right to the first executable statement after the call. So it says press a key to see step 1. Okay, so I just press a key, boom. Now we're ready to call step 1. So we call that process. We're at the start. We go in, it says unplug the dryer and move it away from the wall. We hit end, boom, we go to step 2. Now again, it came back right to the first executable line of code after the call. So I'm just going to go ahead and hit run now. So step 2, step 3, see step 4, boom, done. So there's all of our steps. They all displayed really nice on the screen. We're done. Okay. So again, very easy to create those modules in Raptor. We do a right click up here on one of these tabs and we say add a procedure. Okay. Now here's what's really nice is if I need to modify that procedure, again, remember that very first screen we saw at all the different the parameters and things. If we need to modify that, we can just do a right click and say modify procedure, and it brings that screen up where we can go in and modify it. And we'll see that a little bit later as well. Okay, so multiple module call. Again, this is what the flow chart looks like. So now let's talk about local variables. So let's do this. So here's program 3.3. So let's open up 3.3. So I'll grab 3.3. Now let's take a look at it. So here I have start. I have get name, so it's going to call this procedure called get name. So I come up here, here's get name. And what we do is we created a variable called name and we set it to a null value because it's a string variable. And I say enter your name and we get name. Okay. So this guy creates a variable called name and then we ask the user for input to get the name that they want. We come back to main and it says hello name. Well, let's run it and see what happens. Well, right away I get an error. It says, hey, sorry, the variable name is not found. And I'm going, yeah, it is. If I look here in get name, it's there. Here's the problem. This variable name is born right here. it dies right here because that variable is only known by this module. Main doesn't know anything about name. Okay, to start, name is nothing. Okay, so this get name, that variable only lives there. It lives nowhere else. So that's why we get the errors, because main doesn't know about name and the get name does. So yeah, so here we have to get two ages. Declare integer age, display your age, input age, declare integer age, just get your pet's age and input age. Well, guess what? This right here will cause an error because age is already created. We're trying to recreate it. It would blow up and say, whoa, 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 you've already got a variable named age. You cannot recreate it. So let's take a look at program 3.4. So what this guy is going to do is we're going to have a number, and it's going to show what it looks like squared and what it looks like cut in half. Okay, so here we're going to call just two modules. We're going to call show square and call show half. So if we go to show square, we create a variable called number, and it's a 0.0. Notice I got a comment that says real. Now, why would I put a comment real out there? So that, again, remember, flowcharts are a way for us to work out the logic of our program, and then we give it to the programmer, which probably would be us, and it lets us know that when we declare that variable in our code, it needs to be a real or a digital numeric value. So that's why we do that. So I got number 0.0. I got square 0.0. So I created two variables, two local variables. Remember, those guys are born right here. Where do they die? They die right here at the end. As soon as we hit that end, those variables are cleared out of memory and done. I get input from the user. I say input, enter a number. I put that into the variable number. I then say square is equal to number, and that caret symbol 2 is a square, basically it's number times number, basically. Exponent, so it's the exponent 2 for the number. And then I go ahead and display on the screen the square of that number is square. Okay, half, I do pretty much the same thing. I create a variable called number. Now notice I'm recreating that variable number, but remember, it's a local variable. That other number, it died. It died at the end, so I can recreate. I can create the same variable name in every single one of my modules because they're born there and they die at the end. So it's not a big deal. So I create a variable called number 0.0. I create a variable called half 0.0. Initialize it to that. I then say enter a number. I get that and I throw it into the variable number. And then I'd say half is equal to number divided by 2. Then I display on the screen half of that number is half. So we run this guy, enter a number. I will go ahead and say 10. And it says the square root of that number is 100. Enter a number. I'm going to say 20. And it says half of that number is 10. So our program works just the way as expected. So the main focus there is to realize that local variables are born when they are declared and they die at the end of that module. So now let's talk about passing. So I want to call a module, but I want to take a variable I've got and pass to it. So let's take a look at program 3.5. So here's what I've done, is I've got this module called double number, okay, and it's got double number right here. So let's before I go on, let's go ahead and see how we created that. So I'm going to go ahead and do a right click here and say add a procedure, and I'm going to call this triple number. And I'm going to be receiving a variable. Now, I can give this variable any name that I want. Okay. Now I'll talk about that in just a second. So we don't have to use the same exact variable name. We can, but we don't have to. I'm going to call this value, and it's going to be brought in as input. Okay, so the input box is checked, the output box is unchecked. I click OK. So there it is. So now what I can do is I can put an assignment in here, and I can say value, notice value shows up down there, I hit the enter key, it grabs value, is equal to value times 3. I click done. I'm going to display the output and say that number tripled is value. Okay, so pretty easy. So again, I did a right click, I added that, I gave the procedure a name, I said what values are going to be brought in, and now to call that back at my main, I just basically say, well, let me do this. So I want to call triple number, so there it is, it comes up, I hit the enter key, I put in a left parenthesis, I'm just going to pass in the number 5, right parenthesis, so I'm just actually going to pass it a numeric value, and that's it. So now when I run this, it says 8, because that's basically what this double number did. It said to just put the result. So it brought in the value. It said result equals 0. So here's what this guy did, is it created a variable, which was probably what we should have done. It created a variable called result equals 0, and I said result equals value times 2, because we really don't want to always modify this variable that's brought into the procedure. Sometimes we just want to leave it be, so we basically create a result in this case to do our multiplications on that value, and it comes back, because we may need to go back somewhere in this module and get that original value again. So let's create a variable to do our calculations with and leave that one alone. Now let's talk about this value variable. This guy is born right here. It dies right here at the end. Well, you're probably thinking, I passed that variable to here, so isn't that variable born in the other procedure? No, it's not. What we are doing is we are called passing by value. And what that means is I'm only passing the value inside of that variable to this variable. This variable value is created right here, and that value that's in the variable being passed to it is passed in. We'll see a lot more of this in detail in just a few minutes, but realize we're only seeing a copy of the variable passed to us. We're only seeing the data inside of it. Okay? So, value is born here, it dies here. So let's take a look at 3.6. So 3.6 has double number. So here's what we do inside of our main. We go ahead and create a variable called number. We initialize it to 0. Again, we put a comment that is a integer. We say enter a number, and I will display that number doubled, and we go ahead and get that number from the user. I then call double number. Now instead of passing a numeric literal, a number 4 in the previous one, I'm going to pass the actual variable number. Okay, so if I do a right click this and say this is what it looks like when I created it. I created this procedure called double number, and I'm passing in, so it's marked as input, value. I then again, I don't think this guy even changed because the value stayed the same. I create a result, value, put result. Now, again, this module did not change at all. It stayed exactly the same as the previous one. The only thing that really changed was the main, because now we're trying to show that we can pass a variable as opposed to a numeric literal. Okay, so now let's pass multiple arguments. So let's take a look at 3.7. So here in 3.7 I said the sum of 12 and 46 is, and I say show sum, and I'm passing in 12 and 46. Okay, two numeric literals. If I see how that looks over here, I've got show sum, and I'm getting an input of num1 and an input of num2. So here it is, start and num1 and num2. I create another result, 0. Result is equal to num1 plus num2. I put that result, it ends. Okay. Realize num1 and num2 and is born here, result is born here. All three die right here. They're gone, out of memory, done, can't use them anymore. So let's see how that looks. The sum of 12 and 46 is 58. If I did my math correctly in my head, that is correct. So, in the spotlight, your friend Michael runs a catering company. Some of the ingredients that his recipe require are measured in cups. When he goes to the grocery store to buy those ingredients, however, they are sold only in fluid ounces. He has asked you to write a simple program that converts cups to fluid ounces. You design the following algorithm. 1. Display an introductory screen that explains what the program does. 2. Get the number of cups. 3. Convert that number of cups to fluid ounces and display on the screen. So what we're going to do is we're going to have, so our hierarchy chart shows our main, and it's going to call show introduction. Comes back to main, and it's going to then call cups to ounces. Okay, and it's going to be passed cups as a real data type. So let's take a look at program 3.8. So here's our main. So we create a variable called cups needed. We initialize it to 0.0, and we got our comment here saying that it's a real data type. I call show intro. Show intro, we come in, notice I'm passing nothing to it. This program converts measurements in cups to fluid ounces for your reference. For your reference, the formula is 1 cup equals 8 fluid ounces. End. Okay. It comes back to main. We say enter the number of cups, and we get that cups needed from our user. We then call cups to ounces, and we pass cups needed, this variable. So we come in here, we get cups, and remember this variable cups is created right here, and what was in cups needed in the previous one is copied to there. We create a variable called ounces, 0.0, it's a real data type. Ounces equal to cups times 8, then we display. That converts to ounces, okay, whatever is in that ounces variable, and then we display the word ounces. We hit end. When we hit end here, realize cups and ounces, boom, dead. We run it. It says this program converts measurements into cups to fluid ounces. For your reference, the formula is 1 cup equals 8 fluid ounces. So I'm going to type in, we got 4 point, it's got to be an integer, 4 cups. And so that converts to 32 ounces. Okay, simple enough. Again, here is the flow chart, what it would look like to flow chart this on paper. So now we talk about by value and by reference. So some languages were able to pass the actual variable itself to that procedure. When we do that, when we change it in that module, it changes it in that original variable. When we pass by value, again, we are passing just the value to the module, and it's being put into a brand new variable. The original never ever changes. It stays the same. So when we modify that variable, that by value variable in our called procedure, When we come back, the original was not touched at all. Now, most languages would only have pass by value. Some languages like Visual Basic and I think Python, a few others, are able to pass by reference. Raptor doesn't have the ability to pass by reference, but we can kind of fudge it to make it work. So let's take a look at 3.9. So here's 3.9. We basically have a number that, can I make this bigger? There, ooh, let's do that. So here I have this variable number. I set it to 99. It's an integer data type. I say put the number is number. So I go ahead and display what that number is. Then I call change me number. So I come over to change me. So again, I pass in number. Again, it receives it by value. Remember, by value says only the value got passed, not the actual variable. So that value is created right here, and 99 is passed into it. So I'm changing the value. My value is now equal to 0. I put now the number is my value, so it's going to display 0. When we come back to main, it says put the number is number. What do you think it's going to be? Well, like I said, since it's passed just the value to that module, that variable change, when it comes back, it still has 99 in it because it didn't change the original. So when I run it, the number is 99. I'm changing the value. Now the number is 0. And then when it comes back, it says the number is still 99. So realize when we pass things, what happens to the original variable and what happens to the by value variable. Now again, in 3.10 is the same exact program, except what they do is this. Is in a real world situation, if we had the ability, we would say module set to 0, integer ref. Now the ref says pass me the actual variable. Don't pass me just the value, pass me the variable. So now when I change that value and pass it back, now that variable is actually changed. So here's what we're going to try to do here. So I've got X, Y, and Z. They're all three integers. I've put 99, 100, and whoop, that should be 101. I then display what each of those contain. And then I call set to 0, and I'm passing in X, Y, and Z. And then I basically display a line, and then I say, now, here's what I'm going to do. I'm going to modify this procedure. And instead of just bringing that value in, I'm also going to say I'm passing it back. Now, the only problem is this. We'll talk about it here in just a second. So I'm going to run this, and let's see how it looks. And it says X is set to 99, Y is set to 100, Z is set to 101, and then X is set to 0, Y is set to 0, Z is set to 0. So I guess it did work. So how did that work? Well, here's why it worked. I told it to not only bring that value in, but also pass it back. So that really is it's not really by, I guess it sort of is by reference. Yeah. We'll call it by reference. So basically what happened is we modify this value here, and then when we hit end, it doesn't die. It actually sends that value, well, it does die. Okay, so let me kind of get my head around this. Here's how it works. In our main, in our main, we have this X. Now it has a name tag of X. So it says, it's got right here up on its shirt, it says, hello, my name is X. When it is passed to set to 0, when it's over here set to 0, when it's got input and output, it says, hey, it now has a new name tag. It's called value. Now, can set to 0, here, can it see the X name tag? No, it cannot. It can only see the value name tag. So when X comes in, it's got 99 in there. So right now value has 99. I come in here and I say set value to 0. When I hit end here, it basically passes that value back to X as 0. And the name tag value gets ripped off, and then we come back to main. X now has a 0 in it. So when I hit this set 0 and I'm passing Y, X now has 0 in it because I passed it back. So kind of, we'll call it a fake by reference. So I passed the value to set to 0, and then it passed it back and put it into X. Okay, I didn't actually pass the reference of X to there. So it basically worked like I wanted it to. Okay. So again, I put a line, and then I say put X is X, Y is set to Y, Z is set to Z. So I guess it did change. Okay. So big difference between passing just the value or passing the reference. So here's our in the spotlight. It says in the previous in the spotlight case study, we developed a program that allowed your friend Michael to use in his catering business. The program does exactly what Michael wants it to do. It converts cup to fluid ounces. After studying the program we initially wrote, however, you believe you can improve the design as shown in the procedure code. And what we're going to do is we're going to now call a procedure to get the cups. When it comes back to main, we're going to take those cups and pass them to real ounces. So let's go to, this is this got to be 311, I think. Yep. So I create my variable called cups needed. It's 0.0. I just describe it as a real data type. I call show intro. I don't want to go through that again. That's the same show intro as we saw before. Then I'm going to call this new procedure called get cups, and I'm going to pass cups needed. So when I come over here to get cups, notice I'm passing in cups, and so I'm bringing it as input, and then I'm passing it back as output. Now realize I'm passing just the value in, and I'm passing just the value back. It's not really being passed for reference, and I kind of put that in the code there. But so anyway, so I display to the user, enter the number of cups, and I get cups. So then when I pass cups back to main, again, it takes that value that I got from cups and puts it into cups needed. Now I can call cups to ounces cup needed. I notice I'm just bringing cups in as input. That's where I do the conversion, display it, and we're done. Okay. So again, I run this guy. So it says this program converts measurements and cups to fluid ounces. For your reference, the formula is 1 cup equals 8 fluid ounces. So I type in 4 cups, and it basically says that converts to 32 ounces. So life is good. Okay. So what's nice about this is it allows us we can have one variable that we create, and we can pass it back and forth between all these different modules, and I can modify it here, and when I get back it's got the modified value, and I can call it over here and now displays that modified value or uses it in the calculation in this case. So passing by reference and passing by value, very, very important things to understand here. Again, here's a nice flow chart that we can utilize when we create our Raptor programs. But again, realize the by reference is not a thing we can do. We can kind of fudge it and make it work. Now, this is another thing we cannot do in we can't do this in Raptor. And this is a thing called a global variable and global constants. So let's take a look to see what I mean by this. So here I have, so here's my main, okay? So here's the main, and outside of the main I have declare integer number. So that guy is in the actual outside of the main. So here's what I want you to think about. When we create this program, it's got a big huge rubber band around everything, okay? I've got a main, I've got a show number, and I've got, so main can see show number, and show number can see main. The variable number is in the same area inside that big huge rubber band as main and show number. What that means is main can see number and show number can see number. So that number is what's called a global variable. Now again, we don't have that ability in Raptor, so we kind of have to do the by reference thing. But just realize when we get into a programming world that we can create what's called a global variable. So let's take a look at 312 and see what they mean by that. So yeah, again, this number should be outside of here, and again, since I can't do that in Raptor, I create it inside of here, and I say get a number, and then I call show number, and again, show number is just basically I need to have that as output as well. So it just basically then the number you entered is. So again, this looks just like every other program we've done so far. Again, we can't do a global, but just realize that's available, not in every language, not in every programming language. We cannot create a global variable in some of the different languages. I don't know if Java allows a global. I know VB does, but yeah. Again, we can't pass by reference. No, no, there's no global in Java. We can't do global in Java. Yeah, Java just forces us to do the pass by value. So anyway, so again, just kind of put that in your back pocket and kind of to realize it's available in some languages, but not all. Let's take a look at 313. I think they're going to utilize the global variable a lot more. Yeah. So here's what I've done is I've called this. So again, what they've done now is they've got a global variable called contribution rate 0.05. And again, since it's a global, that should be seen by every procedure inside of our project, inside of our big rubber band. So again, what I had to do is I had to put it inside the main. So I've got my contribution rate, my annual gross pay, my total bonuses, and here I call get gross pay, and I pass in annual gross pay. So when I get it, I just ask the user to get that, and now what I'm doing though is I'm passing in and I'm passing back the annual gross pay. Okay. Then I call get bonuses, and I pass in this total bonus variable. Again, I'm passing in total bonuses and passing back total bonuses. So it's by reference. I then show gross pay contribute, and I'm passing the annual gross pay and the contribution rate. Now in our program in the book, it does not pass in the contribution rate. The reason it doesn't is because that's expecting it to be a global variable. But again, we don't have that ability, so I go to show gross pay contribute. I'm receiving gross pay and contribution rate. I create a new variable called contrib. Contrib is equal to the annual gross pay times the contribution rate. Then I say the contribution for the gross pay is $ contrib, and I end. Realize this is a new variable, gross pay and contribution rate, and contrib die here, and these two variables are passed back. Then I say show bonus contrib, total bonuses, and contribution rate. So I'm basically calling this module called show bonus contrib, and I'm passing the total bonuses and the contribution rate. So again, I'm just bringing these in because I don't need them back. So again, I create a variable called contrib, set to 0.0. Contrib is equal to total bonuses times contribution rate, and the contribution for bonuses is $contrib. Boom, done. Okay. So if I run this, I'm going to say the annual gross pay is $50,000. The amount of the bonus is $5,000. And so it says the contribution for the gross pay is $2,500. The contribution for bonuses is $250. Okay. Okay, so that one really didn't show us anything new because we can't do global variables, but just realize that, again, global variables aren't available to every programming language, but they are available. They're kind of nice. It's kind of nice to have a global variable because you can just have that one thing set, in this case, a constant, and then basically pass it to all of the other variables. Now, what's nice though about having this contribution rate set here and then passing it is if I needed to change that contribution rate to, let's say, I'm going to change it to 6%. And now when I run it again, I'll notice it's now 3,300. Okay. Now again, and I didn't want to. So again, if I'd never ever want to duplicate code, I would not want to have to go in here to this this show gross pay contribute and then actually create a constant called contribution rate. So again, it saves us from basically duplication of code. Okay. So what we've done in this chapter is we have learned how to break our program up into modules. We've learned how to pass variables from module to module, how to pass it and get it back. We talked about by value, by reference. We talked about global variables, but just realize they're not available for every language. Raptor is a great program for learning how to flow chart. It does pretty much most everything we want to do here. So again, if you have any questions, please contact me. We can Skype, we can talk, whatever you need to do, just let me know. And we'll see you next chapter.